Greeting everyone. So, in previous classes, we have discussed Ohm's law and theory of current and all. Today, we are going to start the electrical appliances. In this chapter, you will have the second most fundamental electrical appliances, that is the resistor. See, we have three basic components of electrical devices. That is your capacitor, resistor, and inductor. Okay, so these are the three basic types of devices, and everything else will have the combination of these three. Okay, so in previous chapter we have studied, we will upload that also. So capacitor we have already studied in previous chapters, and resistor we are going to start. See, and inductor will be our upcoming chapter. So whenever I say there is a wire which has some resistance or something, the wire will also have some capacitive nature, it will also have resistive nature, and it will also have inductive nature. There is no device which will have purely capacitive or resistive or inductive nature. It is going to have the combination of all three. But if majorly it has nature of capacitance, then it will be called capacitor. So the nature of the capacitor will have what? Capacitor is a device, and what it will have? It will have capacitance. Resistor is a device and it will have resistance. Inductor is a device, it will have inductance. Okay, so if you don't know, even the resistor, if you what you have studied in previous chapter, that also have some, it will also have some resistance. It will have resistance in maybe milliohms, maybe in hundreds of ohms, or maybe in thousands of ohms. It depends on the type of capacitor you have built. Okay, so what we do in 12th class, we study the devices assuming they are ideal. Means if we are studying ideal capacitor, that means it will only going to have capacitance. If we are saying we are going to study ideal resistor, then it is only going to have resistance. And if I am studying ideal inductor, then it is only going to have inductance. But as I said, they have partial character of each one. Even the wire which you have, it has parasitic capacitance. If you do electrical engineering, you will know that is the reason that if you have some power outlet, and this is your live wire, this is your neutral wire, and if someone touches the live wire, but he is not holding the neutral one or ground one, he is wearing shoes. Okay, so even though he is not forming the, he is not completing the circuit, yet if you do this, you are going to feel the shock. Why? Because even though human body is not very conductive, but still it has some partial conductiveness. Means you are very bad conductor, yet you are conductor, and ground is very good conductor, and you and the ground are being separated by one insulator. And if you know capacitor, the basic idea of capacitor is what? Two conductors separated by some insulator, and that is, you can see here. And because of this, you form actually what? A circuit, not very strong, but you do form a circuit, and that's why from this current goes to ground, and you feel shock. Even though you are not completing the circuit with this power light, yet you feel the shock because your body has something called parasitic capacitance. Similar to your body, other materials also have parasitic capacitance, and they also have parasitic resistance. Just like I said, you are behaving like a capacitor, but your body is not very conductive. That means you have resistance also. That means you have the nature of capacitance, and also you have the nature of resistance. That's what I'm saying. Each component will have partial character of other two. But when you are studying the ideal device, you will assume that it has only capacitance, resistance, or inductance. That is the basic approach we are going to do. So when we study in 12th, I will not even say we are studying ideal resistor, but you have to assume until I say otherwise that the resistor, conductor, or capacitor is ideal. Got it? But everything else device you will see it is the combination of all these three. Okay? Okay. So how do you differentiate capacitor, resistor, and inductor between among the given? The idea is if it has like most dominating character of capacitance, then it will be called capacitors. So and similarly you can say it for resistance and inductance. Got it? So what we are going to study? We are going to study resistor. So what is a resistor? A resistor can be anything. It is not. It does not mean it has to be something very fancy. It can be any wire, whether it is conductive wire or alloy wire, whether it has high resistivity, low resistivity. If you have some wire, it will have what? Conductance. If it has conductance, then it will have resistance. Right? If you remember, I told you conductance is inverse of resistance and vice versa. So anything which can flow current from one end to another end can behave like resistor. But typically when we talk about resistor, we assume or we say generally the resistor, if you do electronics, you will say resistor is your carbon based resistor, right? There are many varieties of resistor, but what we are going to study carbon based resistor. Okay, if you go in your physics lab and if you see that resistance box also, if you open that box, you will see the same carbon based resistor which I am going to talk about. You will see the same carbon based resistor there also. Why we are talking about carbon based resistor suddenly? I just even though I said resistor can be anything, the reason is carbon based resistor is very small and it can give you very close to accurate values. So and it is also cheap. But let's say if you want to have a resistor and you want to use copper wire, you know copper wire is very less resistive, or the conductance of copper wire is high. To make a desirable resistor, you have to have a very big length of wire, or you have to have a very thin length of thin type of wire. In any case, it will be very hard to manage the wire. So what we end up having is carbon-based resistor. So what is carbon-based resistor? It is just like this. I might put a photo to show you. This is carbon-based resistor. It will have two ends. Okay, resistor is your bipolar, means it does not have any polarity. So carbon based resistor is just like I said, it is very small and it has some colors on it. And from the color we can judge whether it has or what it has as a value of resistance. So it can have 4 band, it can have 5 band, whatever band it can have. So that color coding will tell you what is the resistance of the wire. So in similar way, what we are saying resistor, first type of resistor what we have discussed is carbon based resistor, just like I have shown. And what is the purpose of resistor? Or what is resistor? I don't think I need to elaborate that more, because the name itself is telling you resistor is something which resists. Which resists what? The flow of current. That is your resistor, and the character it will have, that will be called resistance. So it is a device which resist the flow of charges. That is your resistor. Got it? So it is not something very unique or fancy. It is very basic because already you are familiar with resistance. So it is not that complicated to discuss. Okay. So the character it will have is resistive character, or it will have resistance which you measure in ohms. Got it? That we have already discussed. So color coding of carbon-based resistor, color coding of carbon-based resistor, and how to evaluate the resistance from the color. It is very basic. We might upload a video to evaluate the resistance from the color coding, but it is very basic. Some mnemonics will help you to remember the data, and you can use that data to evaluate the resistance. Okay. So what we are going to discuss, just like I told you, this is ideal resistor. So ideal resistance will have 100% resistance, no character of inductance, no character of capacitance. And what is the resistance? It is a device which resists the flow of charges in simpler terms. And the types of resistor we have discussed, this one. Okay, there is another type of resistor also. If you have seen any music box or something, home theater type something, the volume of the button which you can rotate a knob, the volume knob you can rotate left or right to increase the volume, that is called as, that is the name of that knob is potentiometer. And inside potentiometer what you will have? You will have an alloy which is winded up in a circular manner, helical manner, and if you rotate left or right, it adjusts the length of the wire, and thus you get higher or lower value of resistance, and therefore you get the higher or lower volume. So there are many varieties. So we will upload some picture to see there are what types of varieties of resistor you can see. Okay, resistor you can see. So what we are going to discuss now? So what we are going to discuss? We are going to discuss resistor in circuit. Resistor in circuit. Okay, and in this chapter we'll assume source is DC. Okay, so for now we will assume the source is DC. Right? In upcoming chapter we'll see resistor in AC circuit also. So when you talk about resistor in circuit, it has only two types of combination in basic terms, that is your parallel and series. Okay, so in parallel and series what you do, you find the equivalent resistance to evaluate how much current is being supplied by the source. Okay, so resistor in circuit it will have two types of combination. Two types of combination. Okay, see the combination. First is your series. Got it? So if you have a resistor in a circuit, let's say R1, R2, and the source has some potential delta V. You can see the current will flow like this. Also, this is your wire, and we'll assume the wire has no resistance. Actually, it will have some resistance, but we'll assume it has no resistance. And here you will have, let's say, ammeter. Let's say it is showing you I reading. Okay, so what you will see, if you have resistor in series, it is going to have current, same value of current. Why? We will discuss that also. But if you see, if you connect potentiometer in parallel to resistor, what you will see, they are going to show the different reading, assuming they are of different values. So one can show V1, one can show V2. But if you do the summation of V1, V2, in this case, you'll find it is equal to potential supplied by the source, assuming the wire has no resistance and battery has no internal resistance. And the current being supplied by the source is same for R1 and R2. Right? So this circuit can be simplified into much smaller circuit where we can have the exact same battery, but we can replace both resistors with one resistor. See, the circuit is different, but few parameters are going to be exactly same. The idea here is the resistor which we are replacing or substituting instead of these 1 and 2, let's call that R equivalent, and the idea is this R equivalent will withdraw the same current which they were withdrawing combined. Got it? So if you put the ammeter here, the ammeter is going to show you the same reading of current which you have seen there. Right? This is the idea here, and because there is no other resistor, so if you put the voltmeter across it, the battery potential is delta V. It is also going to show you delta V. Got it? So what you found here, in series, the potential difference between R1 and R2 will be differ, but the current going through them is going to be same. Got it? Current going through is same. And you should know that potential difference of resistor can be written as current passing through that resistor times their resistance. Current passing through the resistor times their resistance. But so what we can see here, that V1 is what? V2 plus V1, V2 is equals to delta V. So if you see this picture also, I can see the current passing through is I and resistance is R equivalent. So I can say the potential drop between this resistor is also I times R equivalent. That means it must be equals to delta V also. Got it? And if you see this equation and this equation, and if you combine, what you will see, V1 I know IR1 and V2 I know IR2. This will be your IR equivalent, and you can see I will get eliminated. So R equivalent will be nothing, just R1 plus R2. So in series, nothing is complicated. You can just simply add the resistance and you will get equivalent resistance. Why we are doing equivalent resistance? There is two reasons. Once you find the equivalent resistance, you know what is the total current going to withdraw from the battery, or what is the other purpose. If you see the complicated circuit and you see the what is the total value of resistance, equivalent value of resistance, you can just get the new resistor of the same equivalent value and you can measure the remaining parameters which is required to be measured. Right? So in series, what you see here, in series, I same, but delta V is different. Okay, delta V can be also same, means potential difference between these two can be also same if their value is same. Okay, what we have got here is, what is the meaning of this? Let's say if it has, the source has 20 volt. Okay, so if both have same value, let's say X ohm and X ohm, then it is going to consume 10 volts and it is going to consume 10 volt. But the summation will be equal to the source supply. Got it? But the current will be same in the branch. Got it? So you can also imagine, you can say it like this, in a same branch where there is no junction, the current will remain same. So in series, you don't need to do anything complicated, you can just simply add it. And this series, in this way, you can also make something called voltage divider, because you are dividing the voltage. Got it? Like for easier example, let's say I had a source of 200 volt. Okay. Volts, and I had 2 resistors, and imagine here I have connected some, let's say for example LED I have connected. Okay, so if you have connected LED is very fragile device. You don't want the potential difference between the LED to be too high. So what is the what you want here? You want to have here like approximately 3 to 4 volts between the terminals of the LED, so you don't harm the LED. Okay, so let's see how you will do, and let's say this is your 20 ohm, or okay, let's say this is the 20 ohm, and you want potential difference across the LED, potential difference across LED to be 4 volts. Okay, in that case they are asking you what should be the resistance R, so you can have desired voltage across or potential difference across LED. It is very easy question, you can try. Okay, I will show you what is the idea here. What we want to have here is potential difference across LED to be 4, and if you see this is 220 volt, it is not given, you can imagine plus, you can imagine minus, so this will be your 0, so this will be also 0. What do you want? 4, so here you will have 4, so remaining is your what? 4 is being consumed here, so remaining is what? 216 volts. So the potential difference across R is, this will be still 220, and if you do this difference, this will be 216 volt. Now you can see the potential difference. What you have to evaluate is just the value of R. Now you can do it. How you can do? First, R equivalent will be your what? R plus 20, right? And potential difference is given. You can do a long process also. This will be your what? I times R. This will be your I times 20. Hold on. This is the formula of I, right? Okay. Now we have one variable I and one variable R, and also you know total potential difference will be your what? I R plus the potential difference across R is your what? 216. Now I can simply do what? I into R equals to 216. I is your what? 220 by 20 plus R, right? And into R, this is equals to 216. Now this equation has only one variable, and you can do the simplification, cross multiplication, and you can get the value of R. So if you have resistor in series, it is commonly used as potential or voltage divider. Like if you want to have, if you want to turn your LED with the help of main circuit, just like main supply, you cannot add any enormous value of resistor. You have to find the exact value of resistor, so the potential difference across the LED is desired value, and you can manage the rest. Got it? Okay. So we can do many questions in there, but today it is basic for series and parallel. Then we will discuss one combination is done. and that is parallel. So, okay, one more thing before we proceed. So, in series, another way to understand series is if you have two resistors and one of the end of the resistor is connected to a battery or something, and there one end it is connected to a common point. Got it? So, if you have one resistor, it has two ends, and one end is connected to another resistor directly, and then to a source, then it can be a series connection. In contrast to that, in parallel, what you have resistor and their both end is connected to each other. Then you will have parallel connection. Okay. So here imagine we have connected ammeter. Got it? So this is resistor. This one will have, let's say, R1. This one will have R2. This will have delta V potential. And we can see both ends are connected to the same point. That means this point will have delta V potential. This point will have 0. Means their potential difference is same. But in that case, I current, that current will be different. One will have I1, one will have I2. Which one will be more, which one will be less, depends on their value. The lesser one will have higher current. Got it? So the one ammeter can show you I1 reading, right? Another ammeter will show you different reading, right? But the total current is same. Right, so I will be equals to I1 plus I2. So this circuit can also be simplified. You can take another circuit where you will have only one resistor and you can have another battery of same potential, right, delta V, and here we can have ammeter. Right, so this ammeter, if it is reading, it is giving you the I value, that current value, and the delta V is same. That means this R equivalent is consuming the same amount of current which they are consuming combinedly. But so this circuit is simplified into simpler one. Right? Again, if you see, if you delta V can be written as I times R equivalent. Got it? Here I you can write what? Delta V by R equivalent. But if you see in this circuit, the potential difference among them is same. So the potential difference between them is I1, R1, delta V. Similarly, delta V equals to I2, R2. So here I1 can be written as delta V by R1. Here I2 can be written as delta V by R2. Once you replace the values, you will see what? Delta V by R equivalent and delta V by R1, delta V by R2. On simplifying, you will get 1 by R equivalent is 1 by R1 plus 1 by R2. Simple. So in parallel, how do you find R equivalent? It is just like this, and it is opposite of capacitor, right? In capacitor, you apply this formula in series and that formula in parallel, but in resistor, it is opposite. Got it? And your parallel connection also can be used as voltage divider, but it is a little bit complicated to do it sometime. So that's why most of the time we use series connection as a voltage divider. Alright, nothing complicated. So I'll give you one question that is very basic question. You can try. So this is the circuit you have. You can find R equivalent. Also you find current through each resistor. That is your homework. You can. I have given you the question. You can do it. And tomorrow we'll do the symmetrical type of question. See, basic type of question there is not like there is no point to discuss basic question. So we'll go to symmetry type of question, and then we'll go to higher level.